Dear all, I would like to welcome you all in the lecture series of Basic Electrical Engineering. In this session, I am going to discuss a block diagram approach of solar power generation. So, let us understand the basics of solar power generation with the help of a simple block diagram. So, before moving on to the session, I would like to explain what do we mean by solar energy conversion system. So, we will be converting in case of solar energy power conversion system. So the first point is the solar energy will be converted into useful heat or electricity. Solar energy can be converted either, you can write it as useful heat, okay, useful heat or electricity. Useful heat, or you can write it as electricity. So, by the way, I would like to inform you that solar energy can be utilized. It can be converted either useful heat or electricity. So, let us look at the first system. The system which converts solar energy into useful heat. Useful heat is known as solar thermal system. Is known as solar thermal system. Solar thermal system. On the opposite hand, the system which converts solar energy into electrical energy, or you can write it as electricity. Solar energy into electricity is known as solar photovoltaic system. Okay, solar photovoltaic system. You know, solar energy which is available abundant, it is a renewable source of energy. So you can convert the renewable energy source such as solar energy into either useful heat or electricity. So there is no pollution. Okay, it's available freely. There are different advantages of solar energy system. So there are two type of system which are available. One is solar thermal system, which is shown here. So this is your solar thermal system. Solar thermal system. You can see the large concentrators. These are the collector and concentrator arrangement. Using this kind of collectors and concentrator, you are extracting solar energy and that will be converted into useful heat. Also, another example is solar water heater. Solar water heater. So the same principle, it abstract energy from sun and it will be converted into useful heat. That will be used for boiling purpose. In the top side, you can see another diagram. Everybody have a look on this. Here, the solar energy will be converted into electricity. Okay, electricity using solar panel. This is your solar panel. Can you see the solar panel? Yes, solar panel. So we have the combination of solar panel. Different solar panels are connected together. We can call it as a solar array. So solar panel or solar array, it is basically made up of silicon. It's a semiconductor material. So solar energy will be converted into electricity by using this kind of solar panel. Okay. The basic unit of solar photovoltaic system is solar cell. The process by which solar energy that is converted into electricity is known as photoelectric effect, or you can call it as photovoltaic effect. So these are the fundamentals which you can remember. Now I would like to discuss what are the types of solar energy conversion systems are available. How do you classify the solar energy conversion system? So now we can say that the solar energy conversion system is divided into two types. Detailed classification I am discussing. So already discussed. Anyway, For the convenience, I am discussing once again. One is solar photovoltaic. Okay, you can make a note of this. Solar photovoltaic system. Another one is called solar thermal system. So look at the solar photovoltaic system. Solar photovoltaic system is again divided into two. One is called standalone system. Standalone system. It is also known as off-grid system. Off-grid system. Another one is called grid-connected system. Grid-connected system. Grid-connected system is also known as on-grid system. On-grid system. So these are the broad classification of solar energy conversion system. Now let us discuss about solar photovoltaic system first. Later on we can move on to solar thermal system. Now I would like to discuss about standalone system. The main purpose of the standalone system is we can operate the load independently. You know, there are two types of load. First type of load is known as DC load. So, like for example, normal light, like incandescent lamp. Okay. Incandescent lamp. Incandescent lamp is an example of a DC load. Similarly, if I talk about AC load, for example, we can say single phase induction motor. Single phase induction motor is an AC load because induction motor, we can use it in your ceiling fan. Now, you can operate the load independently. That is a specialty of standalone system. Second point, in standalone system, we require energy storage unit. You know, the battery. There are different batteries are available. Lead acid battery, lithium ion battery, nickel cadmium battery. So you can see lithium ion battery is most popular. Fine. So even if you go for automobile system, you can see the lead acid battery, but lithium ion systems are most commonly used in electronic system. So if you talk about a standalone system, we require a battery or energy storage system. That is mandatory in case of what I can say, the standalone system. The source of standalone system is PV array. What is PV array? PV array is the combination of solar panel. If the solar panels are connected together, then we get PV array. All right. It can be connected in series parallel or series parallel, depends on the requirement. If you require high voltage, you can connect the solar panel in series. If you require high current, the solar panels are connected in parallel. Like that you can arrange. However, usually panels are connected in series to get the high voltage. Next, the output of PV array that is connected to the charge controller. So usually the DC to DC converters are used as a charge controller, DC to DC converter. There are different purposes for the charge controller. The main purpose of charge controller is to convert the unregulated DC power supply to regulated DC power supply. So using charge controller, the unregulated DC power supply from the PV array, that is going to convert into regulated DC power supply, and that will be directly given to DC load. So charge controller is act as an interfacing device. It is connected between, you can see very clearly, it is connected between the PV array and the load. So it will act as an interfacing device. Interfacing. Let me write it as interfacing unit. Interfacing unit. You can note down this. The second function. So charge controller is connected to battery. Once the load is satisfied, once the DC load is satisfied completely, definitely there are excess of energy during daytime. So the excess of energy can be stored in the battery. There is a battery which is connected. You can see the bidirectional flow. Bidirectional current flow is given here. So the excess of energy that can be stored in battery. Fine. Okay. So daytime, we are utilizing energy from the PV panel or PV array, and that will be given to the load through the charge controller. The excess of energy is given to the battery. During the night, anyway, output of the PV array is zero because it will operate only during daytime. Fine. So the energy supply will be coming from battery to load. I think you understood. So during daytime, let me mark in another ink so that you will understand. During daytime, how about the power flow? Power flow will be from like this fashion, like this, from the source to load. So daytime, during the daytime, okay, during the daytime, the energy flow will be from PV array to the load directly. Okay, so what happens during night? During night, we can say that power from the PV array will not be there. So what you can do? So you can take the power from the battery. So during night time, the direction of current flow will be like this, from battery to load. Okay, the green color indicate during night time the energy flow or current flow will be from battery to load. During daytime, I have mentioned by using the red color from the PV panel to DC load. So this is the way exactly happening during daytime and night time. So to maintain the battery properly, overcharging should be avoided. Okay. Moreover, deep over discharge, deep discharge, overcharging, all those things has to be avoided. So the charge controller protects the battery because battery is expensive. We need to maintain the battery to prevent overcharging and deep discharge. Both are both will be impacting on the battery. Overcharging should be avoided, and deep discharge also should be avoided. So using the charge controller gives two functions. One is it ensures the protection of battery, okay, and it prevents overcharging and deep discharge. Fine. So charge control is very important here. Now, this is the way which is happening for the DC load. Suppose if I talk about the AC load, suppose I want to operate induction motor, single phase induction motor. So can I give DC supply directly to the induction motor? It is never be possible. Fine, because AC load can operate only based on the AC supply. So what is the remedy? Yes, there is a remedy. You can see the inverter. Can you see the inverter here? The inverter is a power electronic device. There are different switches available. We can use MOSFET or IGBT. It is a voltage control device. If I go for MOSFET or IGBT, both are voltage control device. Normally, we are using MOSFET or IGBT. So the inverter that converts the DC power into AC power by using power electronic switches. So switches are controlled by using PWM, pulse width modulation technique. Okay, that you will be learning in the higher semesters. So the inverter that converts the DC power supply to AC power supply. So what you can observe is from the PV panel, there is a battery. So battery will be storing energy in battery. Fine. So whatever the battery which is stored energy, that is DC power only. So output of the battery, if you look at, it will be purely DC. We'll be getting the DC power from the battery. So DC power cannot be given to the AC load directly. So we require another interfacing device. So we are using inverter that converts DC power supply to AC power. DC power will be converted into AC power. So AC power will be obtained at the output of inverter that will be given to the AC load. Fine. So you can satisfy the AC load requirement. So in standalone system, what is the observation is you can satisfy both AC load and DC load. So initially DC load you can operate directly with the help of a charge controller and the PV panel. You can directly operate DC load, but whenever you are connecting to the AC load, you require one inverter. Fine. This system is known as standalone system. Fine. It is also known as off-grid system. Now I would like to talk about grid connected system. So how about the grid connected system? Let us understand what is the specialty of grid connected system. The first point you need to notice that in case of grid connected system, we are not using any energy storage devices. No batteries is used. No batteries are used. Fine. Here, what is the specialty? As we can see, there are solar panel. Okay, it can be formed in array also. Combination of different solar panel that will be formed solar array. It is the main source. It's a renewable energy source. Then output of solar panel. Okay, it is a DC power. Definitely will be getting DC power. So that will be directly given to the inverter. What is the duty of inverter? Inverter converts DC power to AC power. Fine. Next, Definitely our primary purpose is to satisfy the load requirement at our houses. Domestic houses are available, domestic loads or house, we can say house. Inverter output will be directly given. Here, inverter output is directly given to the household application. Fine. Because during that time, more power is available. Fine. So, with the help of inverter, we are converting DC power to AC power. The output of inverter is directly connected to the household loads, different loads which are available in our house. The excess of energy, what excess of energy does? Excess of energy that we are going to convert to the grid. We are going to give to the grid. Grid is nothing but it is an interconnected network of power generation, power transmission, and power distribution. So grid will be actually controlled. There are different companies, supplying companies are available like BESCOM, MESCOM, KSCB. There are different authority with respect to the state. Okay, state authority, different electricity boards are available in a particular state. So electricity board that is actually regulating that. So excess of energy will be directly sell to the particular grid. That will be given to the grid. Grid is a receiver actually, receiver. So the excess of energy will be given to the grid. Next question. One device is there actually called net metering device. You can see it as a net metering device. Net metering. What is the use of net metering device? Net metering device measures how much amount of energy will be given to the grid. So based on the energy which is selling to the grid, that is recorded in net metering. It is one kind of energy meter. It records how much amount of energy is selling to the grid. Based on that amount of energy selling to the grid, the household customer will be getting the revenue. Fine. Like maybe 4 rupees per unit. Like that, there are different criteria that we have to check. Fine. So excess of energy will be selling to the grid. This type of system is known as on-grid system or grid-connected system. Okay, in grid-connected system, remember that we are not using any kind of storage system. Excess of energy will be sold or which will be sent to the particular grid. All right. So particular board will be controlling, will be monitoring how much amount of energy is selling to the grid. Based on that, customer can generate revenue also. Next one is called solar thermal system. So what do we know about solar thermal system? In solar thermal system, solar energy is converted into useful heat. Okay, useful heat. Here, the specialty is we are using the collectors and concentrators. Using collectors and concentrators. So we can use collectors plus concentrators. Okay. So we need to use the special type of collectors and concentrators to grab the energy. Okay. So from the solar energy, we'll be utilizing the heat. Okay. So this type of system is known as solar thermal system. All right. So I request you to refer the diagram which I have drawn on the screen. Here, the sunlight is available. So using the solar collector and concentrator, it will be abstracting energy. It will be extracting energy or it will be receiving energy from the sun. And using the solar collector and concentrator, the solar energy is converted into useful heat. So the useful heat is given to the thermal load. Thermal load may be, you can see heater, water heater. Okay, fine. It may be used for drying purpose. It may be used for what I can say room heating. Fine, air conditioning, etc. So this is actually called a solar thermal system. And excess of energy can be used, can be sent to the storage system. There are different storage systems are available. Rochelle salt. There are different type of storage system. Excess of energy can be used for heat storage devices. All right. Furthermore, in order to ensure the reliability of the system, we are using the auxiliary system. Okay, auxiliary system can be used for maintaining the reliability because we cannot predict the sun, the output of what I can say, the sunlight we cannot predict. It is having intermittent nature. Okay, it is not so reliable. That's a major setback of the solar thermal system. To overcome that difficulty, we can use the auxiliary energy system. In case the main system fails, we can use the backup system, that is auxiliary energy system. This type of system is generally called as solar thermal system. Fine. So in this session, we have discussed about the type of solar energy conversion system. Both it is divided into two types: solar thermal system and a solar photovoltaic system. Solar photovoltaic system, we are using solar panel, which will be converting solar energy into the electricity. Moreover, we are having the subclassification of solar photovoltaic system. One is a standalone system, another one is grid connected system. And we have discussed the basic block diagram approach of solar photovoltaic system. Afterwards, we directly came back to the solar thermal system. In that, we studied about how the solar energy is converted into useful heat. If the main system fails, what is the remedy for that? Okay, so these are the fundamentals which is required for, especially for the first year students. So I'll be going for different lecture series for the coming semester students. I'll be making a separate playlist, but this lecture can be used for especially first year students. And they mentioned clearly that students have to study the basic block diagram of solar energy conversion system. If you are having any questions, please let me know. Moreover, you can use the textbook of the Chetan Singh Solanki. The title of the textbook is Solar Photovoltaic Technology and System. It will be useful for those who are working in the solar domain and those who are as a technician. It can be used. It's a really useful textbook. I am strongly recommend this textbook. You can go through that once. Fine. So thank you for watching this video. Have a happy learning. Thanks again.